Okay, so 6.3, the title is Defense Against Infectious Diseases. So, in other words, how does your body defend itself from infection or from getting sick? So, you need to know that there are 3 lines of defense. The first line of defense is your skin. Second line of defense are your white blood cells called phagocytes, or also known as macrophage. The third line of defense is also a group of white blood cells, but they are more specific in targeting a specific pathogen. We call them lymphocytes. All right, so let's start with the skin. How does your skin defend you from getting sick? So there are 3 ways that the skin does that. First of all, the skin is a very thick barrier covering your body, so pathogens can't easily pass through the skin. So it's a physical barrier that prevents your bacteria, your viruses, your molds, your fungi, your dusts from entering the body. So it's a good protective barrier. Other than that, the skin is rich with mucous membranes. So special areas of the body will have mucous membranes. At the same time, sebaceous glands. All right. Both mucous membrane and sebaceous glands under your skin produces a moist and an environment with a low pH. So moist and low pH prevents bacteria from growing. Additionally, your mucous membranes are softer areas of your skin that produces mucus. Mucus is a sticky substance that can trap your pathogen. So it prevents the entry of your pathogens by trapping them and preventing them from entering the body. And you find your mucous membranes, common examples here, your nasal passages, in your throat area, that's why you produce phlegm, and in membranes of your penis or the opening of the vagina. All right. So skin is a physical barrier. It can produce mucus to trap entry of pathogens, and it also has sebaceous gland that provides a moist and a low pH so that it can kill bacteria from the surface of your skin. Okay. However, what if you have a break in your skin, or in other words, you get a cut, you get an open wound. Let's say there's an opening in your skin. So the instant response of the body is formation of blood clots. So I'll put here blood clotting. Now, how is this possible? If there's an opening in your blood vessel, your white blood, your platelets, I'm sorry, it's not white blood cells, the smallest blood component. So you have red blood cells, white blood cells, and then the smallest cellular component in your plasma called platelets. It starts a cascade or a chain reaction. They produce different clotting factors that will eventually activate prothrombin. This is a thrombin, protein found in your blood. Will activate prothrombin to become thrombin. And thrombin will activate fibrinogen to form fibrin. So now you have fibrin. What's so special with fibrin? So fibrin provides a mesh that can trap different blood components so that you can form a clot. Okay, to visualize this, so you have that opening in your blood vessel, and then your platelets, that white smaller cells, will be activated, and they will release clotting factors, which will eventually lead into the formation of this protein material called fibrin. So it looks like a mesh right there, and as blood flows through the blood vessels, some of the blood can get trapped. Okay, now you form that platelet plug or blood clot. Exposure to air will harden this, and that's what you call a scab if it's outside of your skin. Okay, so what if this is still happening, and at some point there was a small opening in your blood vessel because the clot hasn't formed yet. Some of your pathogens, some of your bacteria, while waiting for your blood vessel to form a clot there, was able to enter your blood circulation. Now what? Then we activate the second line of defense here, your phagocytes and macrophages. So these are white blood cells that circulate around the blood, and if they find these non-self or foreign material, they can engulf it through endocytosis. That's why you call it a phagocyte. These are white blood cells that undergoes phagocytosis, so they eat up these bacterial debris. All right, I'll borrow a YouTube video right here. This is seen under the microscope. So as you can see, these are white blood cells as it tries to engulf these bacterial cells through endocytosis. So this is happening real time in your blood. These white blood cells scavenge. They look for pathogens that they will consume through phagocytosis. All right. If the skin doesn't work, the second line of defense doesn't work, your third line of defense is a specific response to your pathogen, meaning it responds to specific types of bacteria, to specific types of viruses. It might be a little bit hard to understand because it's a long process, so let me give you a simplified stepwise process here. So let's pretend this is your bacteria with its antigen right here. So it will enter your blood, and once it's in the blood, your T helper cells, so that's number one, your T helper cells will recognize and say, oops, there's something foreign, and it will actually activate two types of cells, your B cells and your, let me put 2 here and then 3, cytotoxic T cells. By the way, these are all examples of white blood cells. So your T helper cells will tell the B cells and the cytotoxic T cells that, hey, we have an invader, we have a pathogen, there's an antigen floating in the blood. So what will happen is cytotoxic T cell will attack these pathogens. And while it's doing that, the B cells will transform into becoming plasma cells and memory cells. The plasma cells are your white blood cells that are able to produce antibody. Okay? The memory cells, though, will not do anything. It will just remember the antigen. It will remember the pathogen. Anyway, so now that you have antibodies, these antibodies can do 2 things with this pathogen. Number 1, so it can prevent your bacteria from docking, so that's docking into healthy cells. So normally this bacteria will attach to a healthy cell. So this is a healthy cell. And once it attacks, it can kill this healthy cell. But with the presence of antibody, it can attach to these antibodies, the red. And it will prevent the bacteria from docking and damaging healthy cells. Number 2, how do antibodies work? Identification. What happens is they will attach to the antigen right here, and now this pathogen has been marked. It has been marked by this antibody, and this will signal your natural killer cells to respond fast. It will be easier for this type of white blood cell, natural killer cells, to detect, to look for the pathogen. So 2 things, 2 ways how your antibody work. First is to prevent your pathogen from harming and docking into healthy cells. And number 2, as it attached to antigen, it will serve as recognition, and it will help natural killer cells to look for these pathogens and to kill those pathogens. All right. You have another visual representation here if this is your bacteria, as you can see, it has surface proteins or antigens that they use to dock or attach into healthy cells. So what antibodies will do is it will match, or it will bond with these antigens. Therefore, the bacteria cannot be able to fully dock into your healthy host cells. At the same time, another picture here. So your antibody attaches to the surface antigen of your pathogen, and this serves as a marker. If a natural killer cell sees this, it will actively consume and start killing these bacterial debris. All right. Please know that antibodies have a is actually Y-shaped. The two arms right here will have specific shapes here that will match the shape of the antigen. So you have specific antigen that matches to specific antibodies. Therefore, you have different kinds of antigens from different types of bacteria, and your body is able to produce different kinds of specific antibodies to target those specific antigen. And if we go back to memory cells, so as I've mentioned earlier, it's not going to do anything, but it's going to remember the pathogen. It's going to remember what just happened. So if the same pathogen will be encountered in the future, these memory cells will be ready to attack right away. So this won't happen anymore. We're not going to wait for this to happen, but the memory cells will instantly transform into plasma cells that will start secreting your antibodies. So this is a faster and a stronger response to a second exposure. Now, this whole idea here, this whole theory here is how your vaccination works. So in vaccination, you expose the child to an attenuated or a weakened form of your pathogen or your virus, so that the child will produce memory cells, white blood cells called memory cells. And as the child grows up, if it's exposed to these viruses, then the memory cells will just remember. And the child is ready to produce antibodies. Okay, now your skin can protect you. White blood cells such as macrophage can protect you in the blood. Lymphocytes can protect you against specific types of viruses and bacteria. However, sometimes they get overworked. You have a low immune system, and you can't produce as many white blood cells as you can. So what you need to do is you have to go see a doctor, and if all else fails here in the body, we can use medicine. So antibiotics. Antibiotics are antibacterial medicine. It works against bacterial cells. The classic wonder drug discovered that can fight off bacterial infection is penicillin. Please study the history of the discovery of this penicillin. But anyway, this is widely used as a drug to fight off bacterial infection. However, overuse of penicillin can actually lead to a problem called antibiotic resistance. So what is antibiotic resistance? So from the word itself, resistance, the bacteria resists the drug. Therefore, it will render the drug useless. So the bacteria doesn't respond to the drug. Even if you keep using your antibiotic, you're still sick, because it's a different kind of bacteria now. We've learned in evolution that bacteria can mutate. They can evolve easily using their plasmid. They can mutate their gene sequence, rendering them resistant to the antibiotic. Another problem with antibiotics, I'm so sorry, this should have connected from here, not penicillin. So another problem with the use of antibiotics is that we cannot really use it for viral infection because it's antibacterial. Therefore, it doesn't really help if the infection is caused by a virus. Now, we have this disease called, not disease because it's a conundrum.